Hi everyone, my name is Zvonimir and I'm project manager at R Fund, and I'm also Cardano enthusiast. I'm also a stake pool operator, and today I'm going to talk a little bit about blocks, mempools and their size. So as you all probably know, we're talking about Cardano blockchain, and the whole crypto is based on the blockchains, whether it is Bitcoin, Ethereum, Cardano or any other. So blockchain means that, as the name says, it is a chain of blocks, and these blocks contain information. Most of the times these information are transactions, because we are exchanging some value, but it can also be, some data, it can be various scripts, programs, and so on. So here you can see only a small part of the blockchain, since it is only 3 blocks, and what you can see that these dots represent these data, or we can say transactions. And as you can see, there are smaller dots and the bigger dots. What this means or represents is that some transactions can be bigger in size, contain more information, and some can be rather small. And when we are talking about Cardano blockchain, each block has a size of 72 kilobytes. It was recently increased from 64 kilobytes by 12.5%, and now it is 72 kilobytes, and maybe it will increase even more in the future. Comparing to Bitcoin, it has a block size of about 1 megabyte. So you can ask yourself, why does Cardano have this small block size, and I'm going to mention it a little bit later. Also, it is worth mentioning that on Cardano, the average block time is around 20 seconds. What this means is that on average, it takes 20 seconds from one block until the next block is minted, and it is important that this is the average time. So it can be only 1 second between 2 blocks, or in some cases a minute or more. Now I'm going to tell you a little bit about mempools. Mempool is basically a space where transactions are stored until they're written in the blockchain. So these transactions are submitted and accepted, but they're not yet written in the blockchain. And on Cardano, each full node has its own mempool. As you can see here, I have drawn 4 Cardano nodes, 1, 2, 3, and 4, represented by these circles, and each Cardano node has its own mempool. Mempools on Cardano have size twice the size of the block. So if the block is 72 kilobytes, then the mempool will have 144 kilobytes for each Cardano node, full node. And you can see this example of only 4 nodes, but in reality there are many more nodes on Cardano. These nodes are communicating with each other. So each node has 3 connections with each other. In reality, it can be several or tens or hundreds of connections with other nodes. And these nodes are, of course, exchanging information about blocks. When one node or a stake pool makes a block and writes it in a blockchain, then it propagates this block. It says to all the other nodes, oh hey, I've made a new block, and these and these transactions are contained in that block. And then all the other nodes write that down, and they continue to produce the blockchain on that block they recently received. But besides that, Cardano nodes are also exchanging the content of mempools. So when one Cardano node submits a transaction and it is signed and everything is checked that it's possible, and it is propagated to the network, then it is stored in the mempool. So mempool is just a space where transaction is sitting, waiting to be scooped or picked up and contained in the next block. Few things can be asked when talking about the mempool. So what happens if the mempool is full? You can see that it has 144 kilobytes, but we can imagine a situation where one node submits many transactions, and these transactions exceed the total amount of this memory, and then you can ask what happened. Is transaction not submitted, or what happens? In reality, what happens is that this transaction is not accepted in the mempool, and thus it is not submitted in a way that it can be written in the block. So what needs to be done is this transaction needs to be submitted over and over again until it is accepted in the mempool. And now you can ask yourself, how does the mempool, gets cleared of the past transactions? Well, once the new block is made, then all transactions from that block are cleared from the mempools. Because nodes say, okay, we've included this transaction in the blockchain, we no longer need to hold it in our memory to be, remembered. And by that procedure, you get free space in the mempools, and then that node can submit new transactions to the mempool, which are further, communicated with all the other nodes, and then the node which makes the next block will propagate that block to the rest of the network, and then everyone will release that transaction from their mempool. This is just a simplification. I can't really go into it, but this is just a simple explanation of what mempool is. And now what I want to say is that full node has its own mempool, but many people are not running full Cardano nodes on their computers or mobile phones or whatever. One example where people are running a full nodes is Daedalus wallet, because Daedalus wallet is a full wallet. You have to run it on a computer. It takes a lot of RAM memory and a lot of size on your computer, but it is a full node. So you have your own mempool, and when you submit transaction on the Daedalus and it's signed and accepted in one way, then it is written down in the mempool, and Daedalus communicates its own mempool with other Cardano nodes, and then a stake pool will say, okay, we've got this transaction, I can include it in the block. Then it will include it in a block, like I previously said. Then it will propagate that block to all the other nodes, including your Daedalus, and your Daedalus will then say, okay, this transaction was accepted in the blockchain, and I can delete it from the mempool. And usually for most people, this size, 144 kilobytes is sufficient for their own transactions, because one transaction can be, a few hundred bytes or something like that, and more complex transactions, including Bluetooth scripts and so on, can be a few kilobytes. But as I said, block time is 20 seconds, so rarely will people, for their own needs, fill the mempool if they own the node like Daedalus. But when we talk about other light wallets, I would say, for example, Yoroi, Adalite, CC Vault, Nami, and our own Revuto wallet, and many others. Most of these wallets, they have shared mempools. What that means is that a user is sharing one mempool of some size that is, set in advance. It is using it and sharing it with other users. So in this case, if 100 users or 10 users, or it's not important, but some amount of users share a single mempool, then it can be filled much easier. And once the mempool is filled, then new user coming to that mempool and trying to submit transaction will get some error. It will be, depending on the front end, but it can be transaction failed or a mempool full and try again later or something like that. And that is what we have seen recently with, when Sunday Swap went live, and many people were using light wallets because only these wallets currently are able to have a DApp connector and to connect to the DEX. Then these wallets didn't have enough size of mempools, and people are trying to submit, thousands of transactions. And what happened after that is that some people couldn't submit a new transaction because mempool was filled, and it needs to be cleared before submitting a new transaction. What can be done about this? Is this something we should, get accustomed to, or what? The thing is that light wallets can increase their mempool size. And that way it will be much harder for mempool to get filled with transactions, and users will be able to submit their transactions. What I need to say is that once your transaction is in a mempool, it can still take a long time for it to get included in the blockchain, and that has to do something with the way that picking these transactions work, because it is going to first in first out. It is using the first in first out method, and if there are a lot of mempools on of all the nodes on Cardano, and your transaction is accepted in a mempool, that does not guarantee that your transaction will be included in the next block or next 5 blocks or whatever. It just takes time. And also, what people need to be aware of, that there is actually time to live for each transaction, and if transaction is held in a mempool for a long time, then it may be dropped. And I also advise people building on Cardano to increase total time to live for these transactions in their mempools, because people may get their transactions dropped without knowing, and they may be angry later that their transaction was accepted in a mempool and not included in a blockchain. One other solution besides increasing the mempool size is to increase the block size, so more transactions can fit in one block. But we have to be careful with that, because imagine if you have only two nodes on some network in one room connected with the cables, then you have high bandwidth between these nodes, and then the block size can be even 1 gigabyte, and you could easily send this amount of data between these two nodes in few seconds, because you have gigabits per second and even higher internet bandwidths now. But Cardano tends to be really decentralized. So if you have thousands of nodes which are not necessarily communicating with each of these nodes, but only tens or the hundreds of other nodes, then you need to be sure that before the next block is made, that the previous block is properly communicated to all the other blocks, because otherwise you could get some mess. And like I said, it's 20 seconds in average, but sometimes blocks are only 1 second apart. I mean, one slot apart. And in this case, if this node was not communicated and propagated to the network before this one made, then you get a confusion in the network and various things happen. So Cardano tends to have block size that is easily propagated, and if we increase it in like 10 times, then okay, you would have more transactions fit in, but you may have higher latency and propagation problems and so on. And you may ask, why does Bitcoin have 1 megabyte then? Well, Bitcoin has average block time of 10 minutes. So you have enough time in these 10 minutes to propagate 1 megabyte of data. And on Cardano, it could be only 1 second in some instances. So you need to propagate these 72 kilobytes in that short amount of time in order to the blockchain be fully functional. So yeah, that's it. And if you have any questions regarding the blocks, block size, mempools, if you want to get more information about how all of this works, feel free to ask us, and we will be here for the answers. Thank you.